Oh, welcome aboard. Nice to have you with us today. My name is Tor Hansen. I'm your artist naturalist. You might look for my writings on iberkshires.com. I have a column called Berkshire Wild with my writing and description of events of trying to follow what goes on in the habitats in the Berkshires that I've been able to study, such as Mountain Meadow, run by the Board of Trustees of Reservations, and Greylock Glen, now getting a new visitor center, and that in the town of Adams. And also in Williamstown is the Spruce Lionsgate Park, where the parrot and Merlin hawks are prevalent, as well as butterflies. Subject for today is a video all about the silk moths, especially an introduction about butterflies, and my fascination in particular is metamorphosis. And it's a wonderful field for exploring the changes that had led up to the survival of certain species as they get through the changing seasons, from warm to cold, year to year. Also, I just wanted to preview this before I show you the beautiful tie I found at the American Museum of Natural History. This is a book called Butterflies Across Cape Cod, and the title, the main creature feature in the video is the Cecropia moth. So I'm going to turn inside the back cover to show you an illustration I did. It's in the book, done by Mark Mello, Director of Research at the Lloyd Center, with Tor Hansen. And our book is called Butterflies Across Cape Cod, came out 2004. And here's the Cecropia moth. And it's a little illustration, and you'll see it as the main star in the video soon to follow. On this page, you'll see that this traces the shedding of the skin of the caterpillar. So we've fashioned a pretty progressive little book just trying to highlight and illuminate what lives on Cape Cod and actually applies to many of the species found here in the Berkshires. So this is a nice way to get to know the wonder of metamorphosis. We touched upon it because, of course, we couldn't do a compendium. You might find this. You can find it still, some left on Amazon, first edition, sold out at the museum. It's parent organization, Cape Cod Museum of Natural History in Brewster, Cape Cod. Thanks to John Hay, who provided the grant funding. So let's go to, what do we do with artwork that typifies the illumination, the awareness, stimulating the awareness of the wonders of nature on our planet Earth? Well, how about a tie? When you're at a gift shop, there's a reason and a place for ties still. I believe that shows our dedication to the wonders of how artwork can exemplify some facet of life on planet Earth. And this is a red silk tie that not only doubles by showing you the wonders of what a silkworm can do, but how people can then take that silk and render a drawing. It's actually a Dimetrodon, what is an extinct dinosaur, and it has high dorsal fins, characteristic of the Triassic period that occurred, say, in the 200 million years ago, before the Jurassic Park. This is the Triassic, one of the hallmark dinosaurs, long extinct. But we have holdovers in Costa Rica called the basilisk that resemble those very Dimetrodons. So that's available in gift shops in many forms. Ties are wonderful. Now I'm going to show you a wonder work by Tawanda Dinaj of Provincetown, who did this just for me so that I could be close to our creator. You see it has a little religious implications in the crosses, but it's also of the wonder of the falcons, the raptors that appear in the evangelist illustrations and the iconography of the biblical New Testament. Mark, Matthew, Luke, and John. Which one is the eagle? Now, with thanks to the seamstress, the people who make beautiful clothing and keep us tuned in to the wonders of creation, here is a t-shirt fashioned. This is what you see when you wear this. This is the back, and this is the front when you're in the lab You want to show people the wonders in the microscope as to what goes on in our microcosm outdoors, the little tiny world that needs magnification. That's the Luna moth. And you'll see briefly a Luna moth in the video to follow. A long tail, beautifully green, uniquely camouflaged in a sea of green leaves. Now, here is a t-shirt. Comes from Cecropia, who was the first king of Athens. That would be Attica in those days of 550 BC, before Christ. That's a long time ago when the first king of Athens was named Cecropia. And Cecropia was the referee between a disputed who would have the hallmark item so precious to the Greek people. Poseidon offered water, Athena offered olive oil, and so the choice was given. The olive oil prevailed, and Athena won that little dispute. So Cecropia was a referee at that time. So there's many facets. What does it mean? It means he with a feather in his cap. That's what Cecropia translates as. And you'll see the moth has very plumose antennae. Okay, so let's go to the video. Oh yes, so welcome aboard. This is a wonderful way to see butterflies through the lens of a camera. The camera is mostly digital, a combination of years, back years Minolta to Canon, XTI, XSI, with very fine lenses, telephoto as well as looking into the microcosm. So here we are. This is our first picture. This is actually a wonderful wind chimes fashioned by someone gifted in ceramics, making clay butterfly with just the vein showing. You can actually look through and see, you can see the grass through the butterfly, but with holes made with fish line, looks like 40-pound test, nylon to attach the clay chimes that ring when the wind stirs the butterfly. What it exemplifies is some butterflies are in decline. So we have to find ways, as naturalists and stewards of our planet's resources, to safeguard habitats and keep in mind how we replenish vanishing populations. Wind chimes echo the gentle spirit at large. Oh my, you've looked close into the microcosm. What butterfly is imbibing and searching for nectar at rabbit's foot clover? This is the American copper Hypophleus. It's a beautiful little lycaenid, family Lycaenidae, and it uses its tongue or its coiled proboscis, sort of like a coiling flexi straw. And it will imbibe at milkweed and clover and almost any nectar-producing flowering plant, the all-important flora that nourish our butterflies. There it is at milkweed. And so over the years, attention got into the butterflies of Cape Cod, where I lived for over 40 years. And it came to pass that we decided, Mark Mello and I, and John Hay at the Cape Cod Museum of Natural History at Brewster. John Hay became the patron who provided the grant money so that we could continue research. Mark is director of research at the Lloyd Center, that's South Dartmouth on the mainland. And Cape Cod Museum is at Brewster. So in order to create such a book, I got lucky with the photographs, impressed John Hay. He sponsored the book, over 11 years of official research. And we came up with, I'm gifted as an illustrator, so I illustrated many facets of the biology of butterflies. Here, Cape Cod Museum of Natural History in conjunction with the Lloyd Center for Environmental Studies at South Dartmouth. And the two of us put together quite a progressive book, treating with labels the head of the caterpillar is to your right that has labels as to some of the organs and organelles that exist that go through quite a change when it becomes a butterfly. Thus, the metamorphosis is the vehicle for change, and we see different organs like the coiled proboscis, the chocolate chip, huge compound eyes, and the huge different antennae not present in the caterpillar, but evolved into a spectacular, successful creature called the butterfly. So here's the Cape, from Provincetown at the top all the way to Chatham and Monomoy on the center right, all the way down to Falmouth. Let's see, down here is Falmouth. At any rate, if the mouse is not there, let's proceed. The Cape has 26 different habitats studied in our survey over 11 years. So we came up with quite a difference as to what butterflies live where. And I devised this from a Tibetan prayer jewel. I found this in the town of Chatham in a beautiful shop run by some Tibetan refugees that have set up professing the beautiful jewelry and rugs and all sorts of articulos and clothing from Tibet's artists. This is a jewel that typifies the female releases a pheromone. It attracts the male and the female mate, and they produce eggs. And the eggs, then as you go up the ladder here on the right, there's a coiling wire that suggests a caterpillar, followed by a rather hexagonal or octagonal jewel that represents the chrysalis, and the butterfly at the top. So we're getting the various stages of metamorphosis in a Tibetan prayer jewel. And of course, in prayer, we wish for the return to sovereignty of the Tibetan people who have designed one of the most wonderful religious, artistic civilizations on the planet, where peace and harmony certainly prevail. Now, here's the caterpillar. The monarch hangs upside down, held in place by a little jewel. A jewel meaning a button of silk spun by the caterpillar, and its tail segment hooks into that, and the caterpillar hangs upside down with little hooks that secure its position, and then it will molt into a chrysalis. It sheds its skin rather quickly, and if all goes well, the chrysalis will then congeal in the atmosphere, oxidizing, and the little shell is no thicker than an onion skin. And that is the protective exoskeleton that will prevail through any cold weather. Monarchs cannot withstand the cold winters of New England, so they have to migrate to warmer conditions down in Mexico, where they gather in the Oyamel firs of the mountains in Michoacan. So here's a monarch at Mexican sunflower with its wings folded, and here it is with dorsal view or top view of wings that look like a stained glass window, if you will. Monarch, scientific name Danaus plexipus. The monarch is actually imbibing at Mexican sunflower, which is a big zinnia. You can consult us as to what to plant in the butterfly garden to attract and prepare and provide nectar for the migrating species, as well indigenous overwintering species. Here's Mark Mello, naturalist, author of the book Butterflies Across Cape Cod, and Mark is searching for the regal fritillary. Once prevalent in Massachusetts, regal fritillary, scientific name Spieria idalia, is extinct in New England due to habitat loss and a complex life cycle. Larvae thrive on violets. It's imperative that in order to have fritillaries, their larvae need to feed on violets. So co-author Tor reviews the swallowtails in the book Butterflies Across Cape Cod, published by Patriot Press in 2004. So I illustrated and got lucky with the photographs to typify some 76 species of butterflies and just a glimpse of the moths like the Cecropia. Perhaps now that the book is out of print, we'll maybe make a second edition to include the many moths, the common moths. And you can still find this at Amazon. So tune to Amazon, and maybe you can get this book at a very good price. So the butterflies abound in habitats across Cape Cod, but luckily many are preserved under overseeing organizations. Let's take a look at the New England swallowtails. The joy of graphics artistry, that is, find a person who likes doing artistry on the computer, can actually take about 7 photographs and find a way to infuse them into one, what we call a composite. A composite photo includes 1, 2, 3, 4, 5, 6 swallowtails, plus the chrysalis and a little caterpillar, and a caption. Swallowtail life cycle, 4 stages of metamorphosis: egg, larva, chrysalis, or chrysalid, as you prefer, and adult. Now the schematic diagram portrays the butterfly at the top must find a mate, and thus eggs are fertilized, and then the egg over time hatches out, and little tiny caterpillars emerge and go through 5 instars of growth. 5 instars, that's the time span as a caterpillar between shedding the skin or molting. So 4 times the caterpillar sheds its skin and still is a growing larger larva. Then it will seek a place to anchor its tail end with a silk button, secure that foothold, and spin a beautiful silken girdle or a strand, like a lineman on a telephone pole, can lean out because he's attached to a belt around his middle and do the work that a lineman does. So the caterpillar is a forerunner of such an image. Ingenious as it is, how does the caterpillar know that? By rote, by instinct. Yeah. So you see, this is, the only thing I'm missing is the mouse. I can't seem to find a way to show you via the mouse moving, or so we'll just, I can do it on my screen, but on the televised screen, I don't know. Do you see this arrow as it moves from caterpillar to chrysalis to the hatching or the emerging? Yeah, that's fine. And there is the butterfly spreading its wings to become an adult, ready for its maiden flight. Here's the black swallowtail caterpillar feeding on queen ant's lace. They also love parsley and fennel and wild carrots, and that's in the wild carrot family. Queen ant's lace is host to, as an oasis for nectar, to many species. So the caterpillar is ready to search for a place to place its chrysalis. So it often will choose the bark of a tree, and very often the color of the chrysalis matches the color of the bark. Somehow that little miracle of adaptation occurs, and so it blends in very good camouflage. Black swallowtail chrysalis has evolved a unique camouflage like bark, or in a green phase like a bud on a stem. Yes, so here we go. This is the black swallowtail at Asclepias tuberosa, the orange butterfly weed that can be prolific depending on we the stewards, where we can plant it to enhance the butterfly's environment. This is another schematic diagram available through a wonderful book called Developmental Biology by N.J. Barrell. Dr. Barrell lives in Maine, and he wrote this book along with other books like 1001 Questions about the Marine Life in the Ocean. And so this traces the hormones from the brain and from the prothoracic gland that work in synergistically with juvenile hormone to give you the various molts. Let's go into that in greater detail another time, but for now, that's just a basic outline that it works magically because of the makeup of the DNA, the double helix, the programmer in the life of changes in the metamorphosis of the butterfly. From remote origins in gene pooling, DNA and the double helix have evolved a superb biological diversity exemplified in the butterflies. And in terms of serendipity, the Berkshires offer quite a butterfly diversity. So if we explore this, we also look to the floral components at the base here that have to be in place to keep the system moving, like keep the wagon train processing across the plains. This is the schematic. Okay, this is a cladogram that I designed years ago before the advent of the computerized, much more advanced and accurate cladogram. But what it does is to give you a relative sketch of how the butterflies are related, as if branches of a family tree. And so we're going to look to, this is the one about butterflies, and then here's one I drew up about the moths. Evolutionary diversity, family Saturniidae, the silk moths. And way up near the tippy top, we have the Cecropia moth, the subject of today's discourse. Here's an introduction to a fellow silk moth that is also a giant of the tribes, Polyphemus moth. It's called, named for the Greek one-eyed giant in the Odyssey, Odysseus, Iliad and the Odyssey by Homer, Greek mythology. So it is a very opulent, has wonderful eye spots that make it so intriguing to study. Here's its caterpillar. It's a segment of maybe 12 segments, including the head. And those little segments include the row of reddish spiracles that are windows for breathing per segment, 2 per segment, and little jeweled studs that can be silver and red that enhance the wonder of the creator, who was probably very proud to have made such masterpieces that we see in the insect world. And here we have the cocoons. Looking through the leaves in the oak tree, these pollies can be raised on oak, and they'll spin an ovular cocoon that's white at first and then impregnated with sericin, and inside is the pupa, P-U-P-A, pupa, and that is a sleeping dormant capsule with an exoskeleton that oxidizes in the atmosphere, in the air, and then goes through time until its conditions are right for rebirth. And out comes the adult, and over time, through molting and shedding the skin and spreading the wings, it is now ready to be another lord of the air. Notice those wonderful hyaline windows. You can actually read the date on a penny, on a coin behind and through those membranes that are clear, knowing that the wings are covered with scales, tiny scales like the shingles on a Cape Cod cedar shake house. This is by Elliot Porter, who is a pioneer for nature photography. You may know Elliot Porter through the Sierra Club books. I hope you find them because they're gems, and he could make even a little waterfall into a wonderful work of art, thanks to nature's ingenuity and a good eye. Here he has pictured time changing as the caterpillar molts and then spins a cocoon, and to capture the actual elements of change in the final molt of the caterpillar into the pupa, he has to cut open the cocoon. So it's a good lesson for a young surgeon to perfect that without injuring the very delicate pupa within. And then over time, and when it's time, when the photo period is right, the moth will emerge, spread its wings, and the Polyphemus will fly by night. They can be very common in places. They too are being hit by Compilosura, is a predatory fly that is introduced to quell the gypsy moth, but is actually spread to attack other favorites and insects like moths and butterflies. Luna moth. Okay, here's the Luna moth caterpillar, also a green biogem, How green is your garden? How green could nature make a caterpillar? I often wonder. You'll see that it too has little orange or red windows for breathing called spiracles along the segments. It has prolegs, the big fleshy green prolegs with looks like slippers for feet, clinging to the leaf and the stem, are lost when it metamorphoses into an adult. Only those 6 legs near the head, where this upside-down caterpillar is hanging upside down, those little 3 pair, 6 true legs become the legs of the moth and the butterfly. Green peace, thank God there is green peace, and that we really welcome, peace and harmony throughout the world, and preservation of the species in the marine world as well as on land, the terrestrial world. Off to the side, we see a brown purplish cocoon and the pupa inside. Let's take a closer look at the wonder of the Luna pupa. And all these moths, these giant silk moths, also have cocoons with pupa inside. Like a sleeping pharaoh, the now dormant Luna pupa rests, antennae, wings, and legs arranged compact in perfect symmetry. So ingeniously, the grand designer or the organizer of how those changes accomplish the almost impossible have neatly folded antennae over legs. You can see the eyes, and this may have been a forerunner in ancient Egypt. Now, of course, the moths and butterflies were here before Egypt was a civilization, and before Pharaoh was neatly composed in his afterlife journey in the tomb inside the pyramid. So here's the adult Luna moth. This is a wonder work of nature with hyaline windows, 1 per wing, 4 wings in all, long tails that dramatize its creation, its being, and they turn out to be almost acting like rudders to perhaps stabilize the insect in flight. It's a very accomplished speedster. They can really fly fast and disappear into that sweet gum sea of green leaves, the sweet gum tree, or the tulip tree, and others, especially birches like river birch and white birch. Here is an African Luna moth relative. This is the African moon moth, Argemma mimosa, emerged from a silvery cocoon, sort of upper center. The moth is clinging to that cocoon from which it has just emerged, and after an hour, those wings are set and rigid and ready for flight. Travel to Madagascar, also known as the Malagasy Republic today. Malagasy moon moth, Argemma mitrii, is endemic to Madagascar, found only on Madagascar. And is related to our very own Luna moths. So the genus Actaea spans the globe, as well as other very closely related Luna moths. This one, of course, is Argemma, special to Africa and its subcontinent, Madagascar. So the cladogram, actually, in the computer world, is much more fine-tuned than our arbitrary educated guess. Those, the ones I showed you by my own hand and colored pencil, is only an indication of the thought of what it looks like in terms of a hypothetical family tree. And so in the computer world today, cladograms analyze data put into the computer, and they come up with a better, closer to true way of looking at how insects and creatures are related, according to gene sequencing and DNA analysis. So hooray for the computer again to clarify and present us with a better picture of how insects are related. So here are 2 silk moths together from cocoons that I purchased through Lepidopterist Society Marketplace. They come from Czechoslovakia, and it's through Department of Customs they come so that make sure we don't import dangerous ichneumon wasps, as well as the moths. So when they emerge, they come out of those cocoons, and in the windowsill, I have fashioned a little jade Buddha just for the fun of it. And to me, in this case, he represents the organizer of cellular change. How in the world does a moth or butterfly accomplish the organization of organs and tissues to become what the next stage of metamorphosis is, and to sustain the life of the creature. There's Buddha with a little skipper on its head. I had the skipper on my hand. They seem to accept a human hand. It's gentle. Living European skipper shades Buddha's head. Oh, really? Yeah, so it jumped over to the Buddha's head and stayed there a while, long enough for me to get a picture. So here's the close-up, and Buddha, by the carver's hand who made this little gem, is smiling. And so apparently Buddha's pleased when the butterfly shades him from the very strong sunlight. Oh, ho, 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 indeed. Here is this beautiful, another butterfly called a Baltimore checker spot, roosting on Buddha's head. So these are some of the fun and games that go along with the serious studies of butterflies. What do they tell us? Well, here Buddha represents the life force that governs metamorphosis. Elephants are male and female that produce the zygote. Zygote, in this case, the little amethyst crystal, and the offspring's DNA. So with this in mind, here is the jewel that could be the next generation, and it contains the genes of both elephants. In this case, a lot of symbolism and metaphor. But that's just part of the fun of how we can use set direction to enhance the story of how do we describe the wonder of metamorphosis. Adaptation, natural selection, survival of the fittest, and mutation as put forth in more modern version of evolutionary theory. Mutation is in the genes, and there can be a change programmed when different alleles from different chromosomes unite from fertilization of male and female in two houses to give you a different looking because of the change of the more dominant allele. See, this gets intricate, so we could get into that in greater detail. So here's a good fiddler friend, and the fiddler plays a butterfly sonata for a wedding. Well, why not? Let's get the butterflies involved and then keep them in the garden. Oh, here's an image. This is like a mirage. That is a Cecropia moth that flits past Buddha and the elephants and the zygote. And over here, it's another, a little later on, we added a bottle of an extinct beverage called Gnome, a little gnome at home beverage, and this was lemon lime, but the Cecropia has little hooks on its toes, so it can hook on to the little blips on the glass. Now here's an illustration I did of the Cecropia moth for the book, showing you the four wings, the hyaline windows that are covered in this case with scales, not see-through, but maybe arresting the senses. If we get into the serious side of animal behavior, this could mean aposematic behavior that look like the fangs of a bobcat, or a bigger creature, larger than life, that might fool a predator when the wings are fanned and flexed, and thus to the advantage of the moth. Also, they could be sign stimulus. That is, they may be a certain landmark, a key, when the incoming male finds the female and identifies the female not just by her pheromone, but perhaps visual means. It's like finding your car in a parking lot. Is that my car? Because I know the signs and I left a few markings to make sure I know my car from all the rest. Well, ho, ho, ho. Here's, when I was in 10th grade, the Cecropia moth story came to light. I was fascinated by various trips, continually, every chance I got, go to the American Museum of Natural History in New York. It was a short ride crossing the George Washington Bridge from Englewood, where I lived. We had a wonderful nature preserve there called Flat Rock Brook, and the host of many trees bore many cocoons. And I remember many treks along the railroad yards where the cocoons were abundant. But the museum started me off on the story because in the dioramas they featured a Cecropia. So I decided to illuminate this with graphic artists. So this is courtesy of Zach Swift, who is the artist, the major artist in all of the follows. who works with Cape Cod Photo and Art and Framing in Orleans, Cape Cod. So through the years, I have provided captions and a design, and he's applied them in making of the composite print. Here, the caption and the moth placed to dramatize the wonders of nature. There's our gnome bottle, and there's the caterpillar fully grown feeding on cherry. Went too fast. Now the key here is, why would I show this little gnome? Well, the green mind in butterfly larvae and chrysalis, what green mind can organize the synergistic hormones to complete metamorphosis? Well, it's one of the wonders that really works, and we people are a product of synergistic hormones operating on our behalf. There's the little moth who's come out of its cocoon. It can climb up on the bottle, believe it or not. To the moth, it might be like a skyscraper, but to us, it's just a little heap of glass. But the moth likes it, and it spreads its wings over 1 hour and is ready for flight. Here's why the namesake sticks. The moth is decorated with wing scales that actually approximate fur. And it's a wonder work with many designs of color fields and patterns of gray and orange and red and white bands. And the antennae are so plumose that Carolus Linnaeus, the father of binomial nomenclature, named this for the first king of Athens, known as Cecropes, without the IA in the current spelling. Cecropes was the first king of Athens, or Attica, about 550 BC, according to Robert Graves' mythology of Greece. And the feathers are true to form. These are the antennae that detect a female's pheromones so that they can quick mate before they die. And she will lay fertile eggs the very next night. They'll stay paired for 24 hours. And those antennae are very helpful in locating the pheromone drift in the wind, her perfume that she sends out to attract the male. And the translation is, Cecropes means he with the feather in his cap. So Carolus Linnaeus gave an apt name here, so that today we can play and be glad that people use reference to those wonderful stories and tales that they would tell before the fireside bright, long before modern technology. Now here is how you construct your little cocoonery. You get a basket with, made of organic stems and reeds, so that the insect can crawl out and climb up and spread its wings. Now, once it does that, it's kind of razzle-dazzle that there's such a beautiful creature. May resemble some of the lichens you might find on old logs on the forest floor. You know, the bracket fungi, it's this outer margin suggests fungi. So maybe there's a correlation there. It's part of the mystery of how the moths have become what they are. And you may have some serious fun wondering about the snake eyes at the wingtips. Some lepidopterists say that those dark spots on each wingtip represent the eyes of a snake. And the snake may also have gnashing teeth that might frighten away a predator, like a monkey or a chipmunk or a crow. And when it flexes its wings, the moth has these huge fang-like windows we call reniforms. So there's a lot to it, getting to know your Cecropia. And here's an illustration featuring three almost very similar but yet different caterpillars. From the top, Cecropia, Promethea, and tomato hornworm. So consult our book and look for illustrations, and perhaps in years to come we might have a broader spectrum book. Here's the caterpillar Cecropia. It's about to that time when it will rest after feeding and search for a place to spin its cocoon. Here's the cocoon in the deep freeze of winter. And the cocoons are shielding the pupa within from the freeze of deep winter. They're spun up on twigs of beech plum or cherry, and they have to endure the long winter and the rather brief springtime. So they'll be in cocoons for more than 6 months, dormant, sleeping in a state of diapause. This scene depicts the outer sand dunes of Cape Cod, known as the Province Lands. The Atlantic Ocean, raw, blustery, and busy with wind, is beyond the horizon. That's looking east and northeast. And the snow is melting, but it's also drifting with the freeze and the thaw. These twigs in the front are cherry and beech plum, and they characterize the dark flora that you see across the dunes. That's the home of Cecropia in cocoons. Cecropia cocoons in beech plum endure a long winter. You can search, it's a good time if you like the blustery cold of winter, to trek up to some of these beech plum and cherry groves that are windswept by the ever-prevailing winds, and look for that silken cocoon spun up on the branches. The arm of the Cape leading to Provincetown in the distance is like a barrier beach, and the strong winds have heaped up sand. Sand transport occurs as sand dunes and cliffs, glacial scarp, tumble down in Eastham and Wellfleet and Truro, and some of that sand is swept north and northwesterly around the Cape and heaped up on the beach in berms, and then the wind will push it up onto the new sand dunes, and sands will spill down over wherever there's vegetation to catch the sand grains, so building up the habitat for Cecropia. You may find a little outcropping of beech plum. Cecropia larvae do depend on beech plum if there is no black cherry. So go up close and you'll see that the sand accumulates, building ever higher. And in the process, it is windward to the ocean, but in the leeward side, you may find Cecropia has an advantage to be out of the buffeting wind. The wind can stir and rattle the cocoon to death if it's placed high into the path of the wind. However, Cecropia ingeniously often places its cocoons down close to the sand and to the base of the bush. There's a cocoon. We have found one. But we look carefully and we think at first, oh, it's just a clump of leaves. However, the moth itself knows by instinct that as a caterpillar, it must camouflage its silken cocoon. Perhaps it has an innate memory of marauders who would steal the tasty pupa within, namely birds that would pierce and pull apart the cocoon, or even ichneumon wasps too. Cecropia moth seaside beech plum habitat is a wonder unto itself. When seas are stormy and the wind is high, rapacious surf can steal some of the sand dunes and even pull some of those thickets into the beach and into the ocean, thus destroying the enclave of Cecropia. But usually in the leeward side, as you can see inside those higher dunes cloaked in beach grass and some poison ivy, yes, there are thickets of beech plum and cherry bushes, the home of Cecropia. So when you are there in the summer months, or even if we're lucky to be at the time of emergence, that would be after late May, as the cherry trees begin to bloom, that's about the time when it's warm enough, sunny, and daylight hours are long enough for Cecropia to emerge from a cocoon. You can see the caterpillars left and right a top view off to the right and a side view off to the left for you to familiarize with what to look for. Of course, this doesn't occur early in the spring or early in the summer. It might be midsummer by the time the fifth instar reaches full size. So this is probably late June into even late July. That's it. Well, the moths will be flying even in temperatures in the low 50s. Even when it's raining, the male will be drawn to a calling female. Sandy pathways lead to the beaches. This is all part of Cape Cod National Seashore. Luckily, it's all preserved for posterity through time. And the moths can hang on to a meager existence so long as there's not too much stormy weather. Do examine the cat briar, also known as bull briar, and inside the thorns that provide protection, the caterpillar might stray away from cherry or beach plum and decide it's good to spin a cocoon in the thorny thicket. Well, all of a sudden, you wait for a rattling. You might put an ear to the ground, an ear to the cocoon, and you hear nothing. So the moth is not ready to emerge. But when it does, the giveaway is a slight rattling and a rustling, and you'll soon be glad you stayed put to watch the emergence. Oh my, the surf is up. The waves are crashing, reminding us that we're glad it isn't really stormy weather, because the Cecropia moth will be in that little thicket area off to the right, directly in the path of the surf, so close that it's within a toss of the stone to reach the first wave. Cecropia larvae that feed on beach plums so close to the Atlantic Ocean are vulnerable to erosion when stormy weather can reclaim sand dunes. The green ovular circle here shows us that is a likely place where Cecropia will carry on its enclave, maybe 3 or 4 cocoons within 100 square feet, if we're lucky. What to look for? Well, you might find a mating pair that was mating last night, the male drawn to the female trail of the pheromone, the female's perfume, and it drifts as little molecules in the wind, and the male with his feathery antennae has to decipher the trail itself and fly into the trail of the pheromone to find Romeo to his Juliet. They are in the sand dunes, but sometimes they're a little farther away. And here into the actual Ammophila beach grass, we find a mating pair. When the surf is up, we're glad that it's not stilling the role of the procreation of this magnificent silk moth. Usually the female will hold fast with her little tiny hooked toes onto a twig so that she can support the full weight of the male below, who's suspended by his claspers. Such is the mating posture of these, rather heavy in terms of the weight, more than 4 grams. So she has to hold fast while he inseminates, and his sperm pass into the cloaca, unite with the little ova that are already preformed, and complete the act of fertilization. The process then is where and when will she lay her eggs now that they're fertilized. Cecropia moth's mating pair in Ammophila beach grass indicates moths are near salt water. On Cape Cod, males will fly to calling females through rain and fog in temperatures as low as the high 50s. Well, even while I was a student at the University of Arizona, much fascinated, majoring in zoology, I couldn't help keeping in touch with the Cecropia studies of previous years. So I brought some cocoons with me, and I lived out in a desert stone house, and I drew with pencil, much admiring the work of Leonardo and Michelangelo and all those artists of Italy and France and Europe, the different phases. So we see just out of the cocoon, the female ray hangs onto that cocoon, and so not to confuse the male, it might be that she emerges about between 6 a.m. and noon, and she'll stay put. And that night, she'll emit her pheromone into the air. The wind will take it, and the little male, who's not too far away, but sometimes more than a mile, and in some cases much more, will find that, follow that trail as long as it's traceable, and fly to her and mate, joining abdomen to abdomen. Just out of the cocoon in the upper right, you see the moth just stretching its wings, ready for its maiden flight, as the moth with full wingspan is airborne within an hour. So she'll remain, they would too, as a couple, will remain together for all of the next day. That's almost 24 hours. And that night, the second night, they'll separate, and she will fly to a cherry or beech plum to lay her eggs. She's very fine at selecting just the right leaves, so that probably by natural selection and adaptation, she learns or has an innate memory of just how to find cherry. It might still be in bloom. This is the bloom of black cherry. About that time, the moth is ready to emerge. So it has timed itself very well, so that about second night, she will find a tree that has fully expanded leaves, and then she will lay her eggs. This is a watercolor I fashioned in order to depict the growth and life cycle. If you search the leaves, you may find the first, second, third, fourth, and the final large instar, the large larvae just below the cocoon and the moth. Now the birds are, above is a Wilson warbler, and below is a Blackburnian warbler that I drew in there just to introduce predator-prey. So far as we know, there's no hidden toxin, cardiac glycosides inside the larvae of Cecropia that would repel the hungry birds, but they are studded. The caterpillars are actually covered with armored thorns. They are harmless to us. They do not inject any toxin or stinging fluid. So what appears to be largely bluff also may deter the predatory birds. So the anatomy of a caterpillar is ever so fascinating. So let your inquiry run. Notice these blue vertical ellipses here, one per segment, and then on the far side, that means 2 per segment. There are about 12 segments. Sometimes if you include 2 for the tail, it's 13. This is a remarkable way in which they breathe. The trachea are within, like little canals that capture the oxygen that passes through each little spiracle. These little blue ellipses are called spiracles, and they're actually windows. And over that membrane, or through the membrane, passes the oxygen, the nitrogen that's in our atmosphere to complete respiration or breathing, and making energy come to life to sustain the life of the caterpillar. Cocoons are carefully camouflaged in leaves wherever leaves are available. Somehow the innate treasury in the moth knows just how to wrap the leaves around. It can silk strand by strand coming out of the spinneret, and the caterpillar pulls the leaves in and anchors them in a way that maybe you can't see the cocoon within wrapped in leaves. So here it is, first silvery white before impregnated with sericin. What is a fluid that is almost like your gabardine raincoat to repel the rain and the water when it rains. Well, the cocoon is, much to our senses of surprise, is there's an inner cocoon inside the fleecy outer cocoon. Let's background check. That is a camel caravan, the double-humped camel. It's the cover of a wonderful book you should read by Lucy Boulnois, The Silk Road. And it's still in print, but I think it's in some libraries. It might be available in Book Look in Knoxville, Tennessee, where you can find older books out of print, but still on the bookshelves by people who treasure what people have written. So let's see. Cecropia is not a commercial silk producer. Silk is too difficult to unravel from these cocoons. Bombyx mori is the commercial silk producer by far, say 95%, especially in China, but in India. And silk industry called sericulture is also prevalent throughout Japan. India and other nations all have experimental or coarse silk producers, such as the genus Anthorea. Our own Polyphemus moth is in that genus Anthorea. But over in Asia, there are about 5 different kinds of Anthorea, Paphia, Pernii, Yamamai in Japan, and so forth. And they produce Tusori or Tusa silk. It's much coarser, and it can be made into beautiful garments as well, but by and far, the silk we see that makes ties and wonderful clothing is Bombyx mori, the common silkworm. So that too is, when the cocoon is soaked in hot boiling water, it begins to unravel, and each strand ideally can be almost a mile long. So that's not possible with Cecropia. It's been tried, but very difficult to get one strand of silk. Now, Cecropia larvae spin a second fleecy cocoon inside the primary sacred amphora, enclosing larvae soon to molt into a dormant pupa. That is, inside the first cocoon, somehow this marvelous engineer, the caterpillar, knows how to build another cocoon inside just for security, for Cecropia security, against any predator or the deep freeze, perhaps even initiated by the response to an incoming ice age. Oh yes, Cecropia was around long before any of the known Pleistocene ice ages occurred. But over time, over 2 million years, the ice ages prevailed, and Cecropia probably had to readapt after it was wrenched from the stem by the imposing glaciers. So here we see the wonder of the innate memory. Can we call it memory or innate response? Somehow it knows that it builds even a more sturdy cocoon inside the outer one. And then it begins to go through hormonal changes. It rests ready to turn into a pupa by shedding its skin. You may see here some debris at the base of the pupa. That's the old skin. Holland, an eminent early pioneer entomologist, called that exuve with an EX, just a fancy word for shedded skin. So it forms a cushion underneath so that if the wind rattles the cocoon, it can absorb some of the shock. So you can actually use glass-headed pins to pin back after you've used your surgical training. And this is a great way to train young kids if they want to be surgeons. Even in medical school, it's a great thing to take and emerge already an empty pupa. In this case, can you cut into both cocoons in order to reveal the pupa, but not damaging the pupa? So it takes the skill of a surgeon to practice that. So here's a picture. Let's draw closer to the wonder of the pupa itself. Now, wouldn't you guess that the whole civilization of Egypt may have hinged on how they noticed that when they opened cocoons in Europe and Africa, they may have encountered pupa that also have this wonderful, precise symmetry that allows the moth to congeal in a compact way by folding the antennae over the wings, over the little legs, all pulled in tightly. So that's a great achievement for simplicity and being compact enough to last for many months inside the cocoon in what we call a state of diapause or dormancy, in which the actual pupa is held in suspension. It's all dependent upon the hormones and the glands at work within the caterpillar. Suddenly, after those moltings, we notice that it now has new antennae inside the outer shell and new wings that never had before. So let's start to wonder some more about the metamorphosis itself as we look to what a youngster looked into the cherry leaves, and lo and behold, it found this beautiful rainbow. She called it a rainbow caterpillar. And this is young Soleil Osprey Cole, is the student of nature in Wellfleet, Cape Cod. And of course, now she's much older, but I know she'll return to the wonder of Cecropia that she found. The caterpillar, and her father, Charles Cole, notified me. So we helped her put cherry together when the caterpillar made its cocoon. And in the spring, we waited patiently, and the moth emerged, and she was so delighted to see that she was now able to enjoy the life cycle of the emperor. Cecropia silk moth has a rather fancy name. What comes to mind is amphora. It was often these ceramic containers called, like wine casks that were often pulled up from shipwrecked vessels in the Mediterranean Sea, a mode of travel and trade containing wine or rice or wheat or food. When the ship sank, they were recovered, but the cocoon itself is like a sacred amphora. And Hyalophora is the scientific genus name, and Cecropia is the species name. Well, Tor was very fascinated ever since he went to see the Hall of Forestry in the American Museum of Natural History in New York City. Lucky me, my dad and mom, Leonard and Eleanor, recognized that I was fascinated by butterflies and birds and bees and whatever was in our backyard. And so they would take me on Friday afternoons to the Museum of Natural History or to the Metropolitan Museum of Art or the Bronx Zoo, and so on. A time when perhaps learning in school was repetitive by Friday afternoon. So where we'd go, and in the hall in forestry, I saw my first preserved specimen in a diorama, and that set the stage. And then one day when I was out in the field, I found my first cocoon, and all these studies followed. So when we want to actually get a mating pair, let's say your livestock, the Cecropia moths have emerged, and you want to mate them, you can put the female in a brown bag and put her outside with the opening facing well away from the wind so that the pheromone drifts windward, and then it will go leeward. It will drift and drift until the male receives it, flies to the cage or to the brown bag inside and finds female and mates quickly. So this was a paramount way to really gain eggs, fertile eggs, to raise a next generation, as well as just to witness the marvelous ways of pheromone detection and mate selection. Let's take a close-up look at the emergence. When emergence is nigh, and you can tell, oh my, the cherry leaves, the cherry blossoms are in bloom, and that's about the time to watch closely in the morning. When the sun is up, it's time that the pupa stirs, and you may hear it if you put your ear to the cocoon. you might hear the rustling, and there's a time to make sure you've got your glass of water or your coffee or tea right then and there before it all takes place, because emergence is fast and you might miss it if you go for a refreshment. So watching this tip, the upper tip in the photo, there comes Cecropia. Now Cecropia is so named because the Greek word Cecropes, who was the first king of Athens, known as Attica, had a feather in his cap. And so Carolus Linnaeus, who's the father of binomial nomenclature, the father of taxonomy, giving a scientific name in two parts to each species of animal or plant on Earth, and fungi as well, and everything else, followed suit, viruses and single-celled animals and so on. The moth is he with a feather in his cap. And so out comes the moth. He pushes and pulls and tries to free its legs. It has secreted an enzyme somehow that softens the silk enough so that it actually designed the valves of the doorway to be not so closed so that it could have an easy exit out of the so-called little temporary prison or shelter. This is the moth reaching out. Finally, the legs are free to reach out. The antennae are now deciphering what's happening in the air, maybe reading certain signals of plants exuding their perfumes in this rich array of potpourri in the wild environment. And then, with all those 6 legs at work, with a little struggle, the moth extracts itself from the cocoon and finds a foothold, a place where it can rest, hold on tight, while the hemolymph is the name for blood, insect blood, and is pumped into the wings via a small but true heart. Do they have hearts? Yes. They have a distinguishable heart, like most insects do. They're that far advanced into living form. Now, those wings will take almost an hour to fully stretch out, and the membranes in between will be stretched and begin to harden over the course of 45 minutes. So stay tuned and photograph, keep your camera ready, make fine adjustments as to the f-stop and the shutter speed for maximum optimal light. And do focus, because in nature world today, photographs better they are if they're really in sharp focus. So watching the wings, first the long forewings fill out, then the hind wings will expand to their full size. In about an hour, and waiting carefully not to disturb or attract any predators, she will then begin to fan her wings gently at first, but then a little more with what we call gular flutter. Gular flutter means she's agitating her wings, almost like a hummingbird, in which you'll see them being vibrated very quickly, but that's to stiffen them and make them ready for the kite we'll soon take to the air. Her maiden flight is made possible by these little wing scales over the very thin membranes. If you rub off the scales, you'll see that the membrane is translucent and very thin, and therefore she has to guide herself, even in stiff winds. Depicting her maiden flight might be a little precarious, but then she'll get the knack of it. And it's time that little Coco show us her zeal for first encounter with Cecropia. Of course, I think it's the children's delight to actually witness the moth itself. This is the female now that she's ready to fly, but somehow they will adapt to your hand if you're gentle. So with a little coaxing and just be very calm and peaceful, and the moth will do what it has to in order to find its way. So look at Coco's expression. It's a wonderful feeling that children can relate to, actually seeing this early in life as well as any time. adults too would love to see and let this moth climb on your hands. It's totally harmless, but it has 6 legs and 6 little feet with little hooks. Not quite like a grappling hook, but little hooks that hold fast to anything that is has the structure like bark or skin. And then it will walk itself across the arm. And she's wondering, wow, this is something. And she, of course, the perception is a special time. And it's a delight to see the moth remaining with the person as if there's a bond forming. The moth might just stay there for the rest of the day, but of course we urge that we put it on a tree or help it to a place where it's not obvious to every passing bird. So let us be glad that we have such moths in this ecosystem, and hopefully we take measures as faithful stewards, as Coco looks at us and questioningly to say, how can we take care of this moth to make sure it's in habitat and living every year where it belongs? Now that the moth is placed, of all things, on a necklace, the butterfly is carved in magnetite, and it was purchased by me when I went through the Everglades of Florida. The Miccosukee Indians make necklaces for sale. Miccosukee is an inborn tribe that inhabits the Everglades. So I just had it on the windowsill. When it comes time to examine the mating process, it's fascinating to watch how they go about it. Notice how plump the female is. She contains at least 200 preformed eggs that await the sperm of the male. They're kept in a little pantry. His spermatozoa is especially cared for in the female, that then, before she lays, that's glazed over by the spermatozoa in storage and then placed on a leaf with Mother Nature's glue. The glue that holds the egg onto the leaves or the bark is so special that it can endure the waiting period. As the caterpillar becomes a caterpillar inside the egg, it takes days to do that, but the glue does not wear out until usually 12 days later, the little caterpillar emerges ready to go, and then the glue softens and can wash away in the rain. A marvelous adaptation. Well, Cecropia is enriched with many different elements or organs. This is the female. Notice that her antennae are, let's consider them slender in comparison to the male. But each little filament is filled with sensory cells. And if you look at that under high-powered microscope, you might be able to see the differentiation of little cells that are sensitized to pick up any and all cues in the environment as to what's actually flowing in the air, maybe the pheromone. So she will release from the abdomen her pheromone in the evening as just about dusk. The pheromone will flow into the air, and the male, in comparison, see how thick and wide and plumose, feathery. Indeed, Cecropia with a feather in his cap. Oh my, well, wouldn't you know it, disaster struck one day when I was outside, very close to Cape Cod Bay, where I lived. The Cecropia were in 4 different females placed around the house in brown bags that night. They all mated with 4 wild females, 1 each. And I was out wandering in a state of elation that all had mated and were inside their brown bags, coupled. Well, I didn't realize it until later that there was a very plump catbird following me around. And I said, oh no. As I went back to check on the wing, the mated pairs were all nothing but wings. So the catbird was suddenly much heavier, having devoured all of those pregnant females. Well, I learned my lesson. So it's better to put them in cages so that the birds can't get at them, because once they do, they're at the picnic. Now, this is a female, and she's laying eggs. Look to the branch. This is a lilac tree, another favorite. Sometimes they will prefer lilac. Those little eggs are about the size of a glass-headed pin, and there are 3 of them there in the lower right. Now, once they're placed in a terrarium with some sticks, she'll lay eggs on those twigs or branches. And you see the size, they look like, if you will, miniature bread loaves of bread. Well, there's a time for their incubation, which might be about 12 days, between 10 and 12. And also, if you don't contain the female, she'll lay them all around the house. And it is a bother to go around and try to remove them. How so? Well, a wet, damp paintbrush, a little watercolor paintbrush softens the glue, and you might be able to retrieve the eggs and place them in a terrarium. Well, another great way is taking Tupperware, and at first place you'll see how that brown bag is cut into little pieces just so that the eggs within are then placed into the Tupperware container, and with the lid keeps them. When they begin to emerge, they are on their own, and they are wanderers. So you have to keep them tightly knit. Even if you cut out a part of the screen, the top, and tape some screen in there to make sure that air gets into the Tupperware, you have to have it sealed or they'll find their way out. So notice how they actually have a little, sort of like an egg tooth, like a seagull, but they have stout chitinous mandibles. And those are the chewing mandibles that they'll use to chew the tree leaves. They chew their way out of the eggs. At first, Cecropia larvae are black, and this is the first instar. They're very small, but they're already armored with little spines that sort of deter that hungry mouse. A little farther along, they're in the second instar. They're growing, and the skin can no longer grow with the caterpillar, so it has to molt or shed that skin. Molting is an intriguing process, so do behold that watch, and when the skin is sloughed off all in one piece, the new caterpillar has huge tubercles or spines, and it tries its best and usually accomplishes it because by trial and error and the inner working of all that DNA up through time has perfected the art of molting or shedding the skin. With time passing and growth, there is the molting into the third instar, and now the parade of tubercles announces the first 2 on the thoracic segment are orange and red, and the last one is yellow towards the hind end. So here we have 3 in 1. We have third instar, fourth instar, and at last the giant 5th instar. So sometimes growth is staggered, and not all eggs hatch at the same time. So growth is differential. There is the picture showing the third instar into the 4th instar. Here's the 5th instar, final instar, in which the larvae is now growing and feeding until it can grow no more. So it waits and settles down as the hormonal changes occur within. Then it's time for Brother Eric to select and make another picture. Now, thank God for older Brother Eric is a very successful commercial photographer who knows the value of dramatic lighting. So he showed me with the mirrors and strobes how it enhances the photograph. And there is the shedded skin. The larvae has molted, and you can see how large the tubercles are. The red in front, the yellow along the top, and the sides are blue. It looks like it's ready for the Easter parade. What a gem of creation. And the successful molting is, of course, something you want to see in person just to witness how miraculous it is that it doesn't snag and it can get out of the old pajamas just like that. That is also a little slower than emerging moth from the cocoon. It takes a little suspenders, so I'll show you very quickly. There's before the molting, and here it is just molted, and the skin is fresh and not oxidized yet, but over a few minutes, the colors come out and the skin is less vulnerable, is thicker, and what we call is oxidized in the air. The shedded skin is stickly prickly, but guess what? The caterpillar finds it tasty enough to consume, to chew, to eat, to ingest, and scientists like to think that it might be to gain the protein in the old skin so that it has energy, more energy than not. And that might be an answer. So this is still totally undecided. Many of the hypotheses are not totally proven, so do apply the scientific method to your inquiry. This indicates that the caterpillar does prefer to turn about after molting and consume some of the skin. In some cases, most of that skin. So the perplexing feeling you might get is, well, let's just leave this to the caterpillar, and lo and behold, here is a craft or a bottle large enough to contain almost a half gallon of water to keep that cherry leaves fresh for 3 or 4 days. And then the caterpillars grow and feed and mature, and here's a close-up of what to look for. And look how large they are, just like a long fingerling, filling up with fluid on the inside. And it's the silk glands that actually are taking up a large part of the internal anatomy. The silk is at that time liquid, but it's filling up the silk glands, soon to be exuded as silken threads. Here we have a picture of 2 genetics. This would be a genetics in action. The upper tubercles of the middle caterpillar are yellow, whereas just below him, the caterpillar's main tubercles are orange or red. So there's a task for the geneticist to explain that in terms of the classic laws of heredity. Gregory Mendel was the father of that theory, and it applies through the dominant and recessive and heterozygous forms that fit the charts of integrates of the genetics and how they fall into what we call the phenotype. The phenotype is what you see. That's a fancy entomological word, but it's also ties in what you see as morphology, is the study of this, what you see in the insect. Let's follow in close to look for this spinneret that enables the caterpillar to spin its cocoon. Here's the head in the foreground, but it looks like it has 2 almost like antennae near the mouth. There's hard to decipher where the eyes are, even though the helmet is soon later on to be discarded, and in its place in the moth, it will actually have 2 chocolate chip large compound eyes. This green helmet takes up most of the space of the head, but those little black dots off to the side are ocelli. Those are the true eyes. There's a group on either side. Bilateral symmetry is the rule in these insects. So on either side you have ocelli eyes, little tiny dark spots that actually contain the imagery, the lenses. And the mouth parts are enclosed inside the labium. So it gets a little intricate and complex, but we're also going beyond the mandibles that are not so apparent, and we're looking for, it's hard to determine just what they are until you watch the silk come out of one of those nozzles. So looking to the side, maybe these 2 nozzles will become the antennae later on in the moth's life. And then we're looking for the spinneret. It's like a garden hose turned on, and out comes the liquid silk, designed and being designed and implemented by the caterpillar, it will, without a blueprint, the caterpillar knows how to spin this cocoon. And believe me, it's a masterpiece. It's a work of art. And the head is so flexible with those thoracic segments that here's how it can actually pull the silken thread to the desired point of attachment. And then over time, the cocoon itself takes shape. Have you ever tried to make a sleeping bag while you're in it? Well, that's nearly impossible, but the insects do it. And that's one of the joys of giving credit to the wonder of the moth, the butterfly, and other forms of insects. So over time, the head is the place that is actually the organ that's working most well. The legs cling, and the caterpillar often turns over backwards to make the cocoon a success. So at first you see that it's still white and creamy. Well, it's not finished because it must be impregnated with sericin, a liquid to galvanize, to waterproof the cocoon. Then it spins the inner cocoon, and then the moth is ready to go into a pupa form, metamorphosing into a pupa and diapause. Well, that's pretty much the life cycle, but we're not done here. Now watch, this is very important. Hyalophora columbia is a sister species of Cecropia. Same genus, different species. Columbia lives in Canada and feeds on larch. And it is in 4 states so far as determined by research, that it's Maine, Wisconsin, New York, I think in Michigan, that have substantial larch population of trees. So this is the caterpillar spinning its cocoon to the stem of the larch. H. columbia, silk cocoon spun in larch. So it looks a lot like the Cecropia cocoon, but there are distinct differences. Now, when we have a chart featuring 3 moths, we wonder what's the story here. When 2 distinct species mate, offspring shows features of both. Columbia crossed with Cecropia yields a hybrid intergrade. So on the far left is Columbia, and in the center it is mated with Cecropia, and the hybrid is on the far right. Now, the hybrid moth from crossbred H. Cecropia with H. Columbia, courtesy photos by Gardner Gregory. This is the hybrid moth. And Columbia is quite distinctly, noticeably different in appearance. So the phenotype, you might enjoy using that word, is what you see. The phenotypes appear to be different. Do the moths actually make a hybrid that will successfully be able to make new generations of moths? No. Usually the hybrids, after 1 or 2 generations, life fades and they are no longer viable. But they do like to mate without exacting selection. So this is all the more fascinating because we want to study in depth the wonders of a mate selection. This sequence of photos was filmed by Tor after receiving live cocoons courtesy of Gardner Gregory. He lived in Long Island many years, researched these moths, moved up to Maine, to Castine, Maine, where he had a museum. With crumpled wings, moth emerges and expands wings to full size, ready for flight over the course of 1 hour. So let's watch and see if this hour is captured in, what do we call that? Shortened, abbreviated time lapse. So there's the moth starting to expand its wings. This is the hybrid moth. And first, the wings appear crumpled and the hemolymph is pumped in by the heart into the arteries and veins. And there's the outer forewings and then the hind wings. And about an hour later, she's ready for flight. So that's an introduction to the life of Columbia, Hyalophora columbia. Okay, we're nearly at the conclusion of today's presentation. We're out in Idaho now. Look at this wonderful landscape. This is near Boise National Forest. It is a wonderfully preserved national forest, rich in wildlife and in habitats, preserved in all times so that we don't change things or destroy the fabric of their lives. This is by a road running through from Boise, going east. You come to a place, if you take the left fork, at a certain junction, it takes you to rocky outcrops known as Castle Rock. Castle Rock is a series of wondrous outcroppings preserved as a reserve, as a nature park. And there's a fence around a little tank or a pond, a watering tank that is preserved so that the sheep don't graze and level everything. Well, this is sheep country as well. Sheep come and go and can graze here. And yet there we have beautiful birds like cinnamon teal, shovelers, and so on that fly annually and utilize the tank hunting for food, as dabblers do. This rock is actually named for Susan B. Anthony with a plaque beside it so that you can find it. And we think that those who gave it the name is probably because of the way Susan B. Anthony wore her hair. So look for that when you're at Castle Rock among all the other rock formations. Now, Hyalophora gloveri is yet another species related to Cecropia that inhabits the west of our North America. Gloveri female selects a sorted cherry for larvae. Different from chokecherry, the west is much drier and has evolved a different species of cherry. Range, Arizona to Idaho, Oregon to Colorado. Hyalophora gloveri male is more angular in appearance, less rounded wings, has of course very plumose antennae, is related to our eastern Cecropia. Notice, of course, when you see them, the antennae are extremely plumose. Gloveri has superb feathery antennae to decipher pheromones airborne, so to locate the female. Biologists suggest that elaborate antennae borrowed cellular tissues during metamorphosis, depleting digestive system. They cannot eat or drink as adults. So that applies, believe it or not, it's true that even Cecropia cannot eat or drink as an adult moth. So all this energy to reproduce has to happen quickly, fast, and efficiently. So this is what we think was some of that cellular tissue was taken from the mouth parts and the digestive tract to form very elaborate pheromone mate selection tissues, including very elaborate antennae. So if that's true, luckily we still have these examples in every other way. The moths are really a superb example of the wonders of evolution. Time and the river flowing, the river of life. Now, on a road trip out west, year 2005, I was passing through Mountain Home, Idaho, responding to an ESP message. That stands for extrasensory perception. I returned to visit this home where Bunny's son was, unbeknownst to me, rearing Gloveri silk moths in an ecology study. I shared my Cecropia stories with them. Astonished, we were glad to appreciate his t-shirt logo, "Jesus is my final answer." So in this little bit of a touch into the realm of mysticism and reality, good science, and suggested, is the ESP something that we can trace to? Maybe our Savior, our Lord Jesus, may have had something to call us together, because I had no idea that I was passing this home. What happened was, as I passed by this home, I looked at it and said, "Tor, you may want to stop there and talk to the people. And I just couldn't believe I was telling myself that. So I drove on shortly thereafter. I pulled over in a roadside rest area, and along comes a runner, like a long-distance runner, carrying a torch. And he came over to me and said, "Here, carry this. This is, you would love this too. This is a torch in honor of peace and harmony." That's the theme, and why he's carrying it is to announce that that is what we seek in terms of political answers and solutions to endless warfare. And so I held that, and out of nowhere comes a photographer, takes a picture. So I have that picture of me holding the torch for peace and harmony. The runner takes the torch, continues to run along the road back in the direction of the home. So I decided I better go back to that house. And sure enough, I pull in the driveway. Bunny, who I now meet, is collecting eggs from their chickens, and gladly shows me what her son is doing. So he is with this little cage studying the role of, or the biology and ecology of the Gloveroi silk moth. So they're gentle to the touch, so he could actually just coax the moth onto his hand, and it accepts sort of a bond, whatever you may call it. And the young man is probably so proud that he's pursuing this, and his T-shirt reads thusly, "Jesus is my final answer." So we'll leave this up to the spirit world, and just be glad in it that we have people following their curiosity, keenly interested in deciphering and discovering what wonderful stories arise by studying Cecropia, Gloveroi, Columbia, to name a few others. There's rubra, there's Edwardsi, and Ceanothus in California. So we have quite a continent with the relatives of Cecropia. And there's your Cecropia in comparison at a lilac tree back on Cape Cod. You can see the difference of the two, and yet they're quite similar, and there are subtle differences in coloration and patterns. So, in conclusion, Ayuda el bosque, that means help save the rainforest. That's me standing on a precipice way up high, overlooking the Pacific Ocean, standing on an island, Isla La Plata, outside of Ecuador, outside of Machalia, and there are whales and whale watch vessels to take you there and to see the gray whales and the humpback whales as well. So I do this in my effort to someday be lucky enough to go to see the living quetzal birds of Guatemala and Mexico, Costa Rica, Nicaragua, where they live with those wonderful long scapular feathers that look like tail feathers. They're brilliant colored, green and red. And the butterfly is called a morphocypress, and it glints purple and yellow or blue and white, depending on the angle in the sunlight. So let's definitely keep in mind that we can help save the rainforest by very acute measures to be faithful stewards and preserve through forestation, connecting corridors of trees, preserving mosaic habitats for all the inhabitants. Here's a watercolor I did featuring the crested owl and euphonia birds and woodpeckers and a beautiful silk moth, distantly related to Cecropia, genus Rothschildia, and of course the preceding sketch, and then the final watercolor with the harpy eagle way in the back in the ceiba tree, and some other butterflies in close, and Heliconia drawing a hummingbird. So what can you put into the watercolor you make in order to save the rainforest, Ayuda el bosque, preserve biological diversity? And of course, we look forward to sustaining peace on Earth. Thank you very much. I have enjoyed presenting what I know about Cecropia, and hopefully you'll be able to identify the cocoons you find and consult me. I'm running a column with iberkshires.com here in the Berkshires, And I have a column out with a banner newspaper in Provincetown, Cape Cod. So you can find me through iberkshires.com. And hopefully there's more to follow in our study of the biology, the ecology, the zoology, and of course we need more and more botanists to really get to know the flora on which all these living forms depend. Thank you so much. God bless.